All right, here we go. Part 2 of the answer key for chapter 7. Number 7 says solve for x. So here we have a right triangle with its altitude drawn. This is 15, this side's 9, and this side's x. Now you can do it in two ways. I'm going to just solve using my geometric mean. Remember that the leg is the geometric mean of the small part of the hypotenuse and the whole part of the hypotenuse, the whole hypotenuse. So in this case, I have, here's my leg, so that's going to go here and here. This is the small part of the hypotenuse that corresponds with that leg, so that will go there. And then here's my whole hypotenuse. So that will go here. So now it's just a matter of filling in and solving. So I'll have 15 as my geometric mean, so it's going to go here. And then I've got, here's my leg, so I've got 9, and the whole thing would be x plus 9. And now we're just cross multiplying. 15 times 15 is 225. So we get 225 equals 9x plus 81. Subtract 81, and we get 9x equals 144. We divide by 9, and you get x equals 16. Final answer. Number 8. Number 8, same thing. It asks you to solve for x. So here's your right triangle. Here's your altitude. This is x, this is 13, and this is 6 square root 13. So again, we have geometric mean. This one's using an altitude. So I know that the altitude is the geometric mean between the two small parts of the hypotenuse. So here's one small part. I'll put that here. Here's another small part of the hypotenuse. That'll go here. And now here's my altitude. So that'll go here and here. So now I'm just going to substitute in x over 6 square root 13 equals 6 square root 13 over 13. And now we're going to cross multiply and solve. So we get 13x equals, we multiply these together, 6 times 6 is 36, and square root 13 times square root 13 is just 13. So we get 13x equals 468, and when you divide by 13, you get that x is 36. And there's your final answer. Okay, number 9. Oh, number 9 has a lot of problems to it. So we'll start with the first one. So this is 5. They're telling us this is 60 degrees. Here's our right angle, x, and 60 degrees. So if we redraw this, we think about it, this is our hypotenuse here of a 30, 60, 90 triangle. So remember your ratios. In a 30, 60, 90 triangle, go short leg times 2, and short leg times square root 3. So here we have the hypotenuse is 5, and so I want to figure out my short leg so that I can come back over here and do x. So I know that that means that 5 equals the short leg times 2 because 5 is the hypotenuse. If I divide by 2, I get that the short leg equals 2.5. So that means this right here is 2.5. So now we've got another 30, 60, 90 triangle. So here's my short leg right here. Actually, this is my long leg, sorry. This is my long leg. And I want to be able to figure out the hypotenuse. So I'm going to set up an equation. I'm going to say 2.5 equals short leg times square root 3, and I'm going to divide by square root 3 on both sides. This cancels, and so we get that the short leg equals 2.5 divided by square root 3. And so that's this, 2.5 divided by square root 3. Now to get from the short leg to the hypotenuse, we just multiply by 2. So times 2. And so that means that my hypotenuse, or my x, is 2.5 times 2 is 5 divided by square root 3. And I'm going to rationalize my denominator, so times square root 3 over square root 3. I get x equals 5 square root 3 over 3. And there's your final answer for that part. The second one on number 9. It's like this. Here's your triangle. Here's your right angle. Tells you this is 10, this is x, this is 60, and this is 60. So if I know that this is my short leg here, well, short leg times square root 3, so this should be 10 square root 3. That gives me my long leg. And now in this triangle, this becomes my short leg, and this is now my short leg, and this is now my long leg. So short leg times square root 3 is the long leg. So I'm going to say 10 square root 3 times square root 3. That's my long leg, or x. So x is 10 square root 3 times square root 3 is just 3. So we get 30. The next one on number 9. So now we're dealing with some 45, 45, 90s and 30, 60, 90s. Here they tell us this is 6. And in this case, that's our long leg. So I know that 6 equals the short leg times square root 3. So if I divide by square root 3 on both sides, that gives me this length. So this is 6 divided by square root 3. That's my short leg. Now remember that short leg times 2 gives you the hypotenuse, so I'm just going to take that multiplied by 2. And I get 12 over square root 3 for my hypotenuse of this 30, 60, 90 triangle. Now also remember that in a 45, 45, 90, the leg times square root 2 gives you the hypotenuse. So 12 divided by square root 3 times square root 2, well, that's this value here, the x. And I'm going to rationalize my denominator, so times square root 3 over square root 3. 12 square root 2 times square root 3 is 12 square root 6. It makes my denominator 3, and 12 divided by 3 is 4, so we get 4 square root 6. That's your final answer there. Moving on, the one underneath it. Now we've got a 45, 45, 90, and another 45, 45, 90. And here they tell us this is 10. And here's x. So I know that the hypotenuse in a 45, 45, 90 equals the leg times square root 2. So I'm going to divide by square root 2 on both sides. That cancels. So I get that the leg is 10 divided by square root 2. And so that's going to be this leg here. And I know, again, I got another 45, 45, 90. So this time, I'm going to say the same thing. My x, or my leg, is, 10 divided by square root 2 equals my leg times square root 2, right? The hypotenuse equals the leg times square root 2. So I'm going to multiply by the reciprocals, 1 over square root 2. Do the same thing here. These cancel, so I get that my leg is 10 divided by square root 2 times square root 2, which is just square root 4, which is 2, so this just becomes 2. So my leg measures 5. Okay, final answer there. Alright, next one. We got 2 more to go on this problem. It's kind of long. So here I have another 45, 45, 90, and another 45, 45, 90, and here's my x. They tell us this is 7. This one's a little bit nicer because the leg times square root 2 equals the hypotenuse, and now this leg times square root 2 is the new hypotenuse. So that's just 7 times 2, which is 14. So x equals 14 here. And the last one. Degrees, 90 degrees. So here's 9 square root of 6. That's my hypotenuse, and here's x. All right, so I know that the hypotenuse equals the leg times square root 2. So that means L times square root 2 equals 9 square root 6. I'm going to divide both sides by square root 2 to figure out my leg. So leg equals 9, and then square root 6 divided by square root 2 is square root 3. So that means that this part here is 9 square root 3. Well, again, I know that this is now the hypotenuse. So hypotenuse equals leg times square root 2. So now I say leg times square root 2 equals 9 square root 3. I'm going to divide by square root 2. These cancel. So I have 9 square root 3 over square root 2. I'm going to rationalize my denominator. So we get 9 square root 6 over 2. Square root 2 times square root 2 is just 2. And that's my leg, which in this case is x. So that's our final answer there. All right, number 10. I actually think I made a mistake on the answer key on that one. I think I put 9 square root 3. It should be 9 square root 6, because square root 3 times square root 2 is square root 6. All right, finally, number 10. Number 9 was a long one. The diagonal of a square measures 3 square root 2 inches. You guys have done these problems a lot, so you should be good at them now. So it says it measures 3 square root 2 inches. Find the exact area of the square. Well, everybody should know by now that a square, when you draw its diagonal, is cut into 2 45, 45, 90 triangles. Well, the hypotenuse is leg times square root 2. So that's 3 square root 2 if you actually work it out and divide by square root 2. These cancel and you get that the leg is 3, which should make sense. You shouldn't even really need to do a lot of work. You should just be able to see that the leg is 3. Now area equals the side squared. So area equals 3 squared, which in this case is 9. And remember your units are squared, so 9 inches squared. Number 11. The sides of a triangle measure 4, 13, and 10. Is the triangle acute, obtuse, or right? Well, remember what we talked about, our Pythagorean inequality. If a squared plus b squared equals c squared, then you know that what you have is a right triangle. If a squared plus b squared is less than c squared, in other words, this hypotenuse, the c, when you square it, ended up being bigger than these two parts. That meant that it opened up and it became obtuse. And if a squared plus b squared is bigger than c squared, in other words, this part on the right, the hypotenuse, became smaller than the leg squared, it closed up and it became an acute triangle. So let's see what happens here. The biggest side is 13, so that must be my C. And it doesn't matter between the other two, which are A and B. So I'm going to say 4 squared plus 10 squared is something to 13 squared. I want to figure out if I need to put equals, greater than, or less than here. So we get 16 plus 100, something, 169. So this is 116, and we know 116 is less than 169. And so that corresponds to 116 is less than 169. Well, that means it's an obtuse triangle. Final answer. Number 11. Oh wait, that was 11. Number 12. The coordinates of the vertices of a triangle are 2, 2, 3, 0, and 6, 1, and wants to know, is the triangle right, acute, or obtuse? Well, we're using the same concept that we used here. But we need to figure out the lengths of the sides of the triangle. This is kind of a lot of work, but you can do it. This is the exact same question you guys had on one of your quizzes. So here's 2, 2. Here's 3, 0. And here's 1, 2, 3, 4, 5, 6, 1. I'm going to connect these. And it looks kind of like a right triangle. Maybe it's obtuse. I'm pretty sure it's not acute, but I need to check anyways. So here, distance formula. Everybody should know the distance formula by now. So I've got 2 minus 6 squared plus 2 minus 1 squared. That gives me negative 4 squared. Notice I'm putting the parentheses to show that I'm squaring the whole negative 4 plus 1 squared. And that gives me 16 plus 1, so we get square root 17. Okay, so that's this side here. This side, square root of, we'll have 2 minus 3 squared plus 2 minus 0 squared, which is negative 1 squared plus 2 squared. Negative 1 squared is positive 1 plus 4, so we get square root 5 for this length here. And then the one on the bottom, let's do that in black. So that is, let's see here, 6 minus 3 squared plus 1 minus 0 squared. So we get 3 squared plus 1 squared, which is 9 plus 1, which is square root 10. Okay, so that's this side here. Now we're going to check. I'm going to put this into the Pythagorean theorem, or the Pythagorean inequality. I know that this is my biggest side. Square root 17 is bigger than square root 10 and square root 5, so that's my C. So we'll say square root 5 squared plus square root 10 squared something square root 17 squared. Well, remember, a squared and a square root cancel, so we get 5 plus 10, and then something 17, so we get 15, 17. Well, 15 is less than 17, so this turns out to be obtuse. If it had equaled, it would have been right. And if the left was bigger than the right, it would have been an acute triangle. So there's our final answer. Obtuse. Number 13. State the ratios for sine, cosine, and tangent. This should be easy for you guys now. So, ka, toa. That means sine equals the opposite over the hypotenuse. This is only for a right triangle. Cosine is the adjacent over the hypotenuse. And tangent is the opposite divided by the adjacent. And that's it. Okay, so ka toa. Opposite, opposite. Hypotenuse, hypotenuse. This one is adjacent, it's dark, and hypotenuse. And this is opposite and adjacent. Okay, adjacent, opposite, hypotenuse. Alright, that's how you remember so ka toa. Next. Solve for y. I like the These are easy problems. These are fun. So this is 24.85. This is y degrees, 83. So I need to think in relation to this angle y. I'm given my adjacent and I'm given my hypotenuse. So I need to say this is adjacent over hypotenuse, so TOA, it's cosine. So cosine of y degrees equals 24.85, that's my adjacent, over my hypotenuse. Now remember, whenever you're solving for an angle, you're going to use the inverse trig functions to get rid of the cosine and to get the y by itself, the angle. So y equals, and it was, let's see here, 72.6 degrees. Done. 15. 15 again, another trig problem. This time we're solving for a side. So here's our triangle. 24x, and they say this is 67 degrees. So this time we have the opposite and the hypotenuse. So TOA, so opposite and hypotenuse. So I'm going to say the sine of 67 degrees equals the opposite over the hypotenuse, which is x. Put a 1 under here, cross multiply, we get x sine 67 degrees equals 24, and now I need to divide by the sine of 67 degrees. Remember, this is not multiplication. This angle here is inside the trig function, so I have to divide by that whole quantity. Make sure you're careful when you plug it into your calculator, and you should get that x equals 26.1. Notice this is a side and not an angle, so I'm not putting a degree measure in my angle. Number 16. Solve for AB, the measure of angle C and the measure of angle B. So here's my triangle. I got that this is 24, this is 30, here's A, B, and C. So first, I'm just going to use Pythagorean theorem to find angle or side AB, because all I'm doing, I have two sides, so I can just a squared plus b squared equals c squared. So that's 24 squared plus ab squared equals 30 squared. So this is 576 plus ab squared equals 900. AB squared equals 321, or 324, square root, and we get that AB equals 18 or negative 18. Remember, we don't want the negative answer because this is a side of a triangle. So here's 18. Now I'm going to solve for angle C next. You could solve for angle B, it doesn't really matter which one you do first. And I can use any trig function because now I have all three sides. Well, I'm going to choose to use the 24 and the 30, which is my adjacent and my hypotenuse. So TOA. So cosine, adjacent over hypotenuse. Cosine of angle C equals adjacent over hypotenuse. Now to solve for an angle, remember you always use your inverse trig functions to get rid of the cosine, to get that angle C by itself. So angle C equals, you just plug it in your calculator, and you should get 36.9 degrees. There's my angle C. 36.9 degrees. Now I'm just going to use the fact that I know all three angles have to add up to be 180 degrees to find angle B. So 180 minus 90 minus 36.9, that's what B equals. So B equals 53.1 degrees. Here we go. And I've finished. There's angle B, there's angle C, and there's side AB. We solve for all the missing information. Number 17. I'm gonna stop this now and move it on to a new video.